Hi, welcome to this Open Security Summit session in May 2022. And we're actually going to talk about a topic which I always find insanely fascinating, especially because some of the exploits, but also some of the great things you can do, which is DNS. And sometimes in application, we think that DNS is something we don't really care about, but it's a hell of a topic. And Osman is going to give us a great test, view of how it goes and the threat. So over to you.
Thanks, Dennis. Especially thanks for all Open Security Summit team for joining me in that session. So I would like to mention about how to overcome security stress in this session. But first, introduce myself. And I have 12 years experience in information security. Mostly I'm based in Istanbul, so I have worked lots of different companies especially in the cybersecurity companies. And I'm working as manager at DNSSense. In my role is the global pre-sales and enablement channel. And I'm working on several projects based on especially firewall, SIEM, EDR, NDR technologies, and also the data security technologies. And I'm certified on JEH and trained on CISP. I hope I will get the exam in this year. And also I'm so much experience on developing business especially in the SOC customers and DevSecOps and the multi-attack framework also. I'm an Isaac alumni, and also I'm a member of IEEE Young Professional, formerly Gold. And I'm also an author, especially I have written so much articles in Turkey's popular articles. So first of all, let's talk about what's the DNS query. As you know, it's a basic and simple explanation on there, but we need to focus on that. DNS is coming from all of the components of the enterprise IT infrastructure, like not only for the client devices, but also so much DNS queries are coming from the servers, IoT devices, and the network printers, and anything on the internet side of the enterprise IT infrastructure. All of these components are querying DNS. So, but we know that the legitimate devices or legitimate sources are the DNS query, but also malicious components and the malicious sources are doing DNS. So we need to separate all of these activities, and we need to detect these DNS security threats with the visibility of the DNS site. Okay, why is DNS an ideal target? Because it is the cornerstone of the internet. As we know, not only web communications but also email communications, and another lots of different communications on the enterprise infrastructure using DNS. DNS is the starting point of the communications in the end of the day. And it is really, the DNS traffic is really increasing dramatically. And in the end of the day, this protocol is easy to exploit because UDP 53, it is really so easy protocol to exploit, especially in the vulnerability sites. And we need to build a secure site for the DNS, especially for prevent this exploitation. And as we know, the DNS has been around for over 40 years in the end of the day. Traditional protection is not enough for especially in DNS, because there are really so much sophisticated and complicated threats in nowadays. And I will be talking about this, the popular DNS threats. Let's talk about DNS security threats. Actually, in the list, you will be seeing lots of DNS security threats like DNS tunneling, amplification, cache poisoning, spoofing techniques, subdomain and X-domain attacks, fast flux DNS attacks, for example, DJ attacks, domain hijacking. Lots of these security threats are really vectoring. Some of them is attacking leveraging DNS or DNS queries. Some of them is leveraging the domains or domain manipulations, and some of them is just only focusing to manipulate or attack to directly DNS servers. So, for example, like cache poisoning or DNS spoofing techniques are directly vectoring to DNS servers. So we know that adversaries and attackers are mostly motivated to get the phishing techniques from doing the DNS security threats, DNS security attacks, and to get the drive-by download motivation, and the another motivation like malware propagation, C2 to get the C2 channels or data exploitation. And in the end of the day, we see that DNS security threats are rocking, and so lots of adversaries are using the DNS security threats for these motivations. Okay. And for example, I would like to give some informations about some of them. For example, DNS spoofing or cache poisoning. Well, how it works? Actually, a client would like to go to real website, but he needs an IP address and he's querying the what is the abc.com, for example. And if the attacker already exploited a system vulnerability of the DNS server, and it will be redirecting to malicious website. Okay, the client's query will be going to malicious website, and the DNS spoofing and the cache poisoning techniques are mostly using in the, and we face so much these threats on the enterprise IT organizations. And you can find some descriptions on the CAPEC library. As you know, CAPEC is a MITRE library, and you can find some details, the DNS cache poisoning and the spoofing technique, how you can explore and how you can mitigate of these DNS threats. Also, we need to map MITRE ATT&CK framework. As we know, the MITRE ATT&CK framework is so popular, and if you want to get more details about these DNS spoofing and cache poisoning techniques, you can find easily the details on the MITRE ATT&CK framework. So, for example, for example, resource development tactic, you can find some details on the spoofing and cache poisoning on the MITRE ATT&CK. Okay. The another technique is the DNS tunneling. It's the another popular security threat in the DNS side. So mostly use this technique to, especially the next-gen firewalls, UTMs, proxies, some sandbox devices. Mostly adversaries, attackers are mostly motivating to bypass these systems internally. Okay, so what's the motivation? Motivation is mainly data exploitation and C2 communications, and the tunnels is using like HTTP, FTP, SSH through DNS in the end of the day. And we see the mostly firewalls are missing to tunneling techniques on their system. So it is so important. We need to detect these DNS tunneling techniques in an advanced level. How we can do that? How we can resolve these tunneling techniques on my network? It is a really challengeable point for organizations. Okay. And also you can find the detail about the DNS tunneling techniques on the MITRE ATT&CK framework, and it's under the command and control tactic, and you can find the detail sub techniques on there. And some APT groups are really using DNS tunneling techniques. For example, APT 41 is always using the DNS tunneling techniques for their C2 communications. It is so popular. The another popular DNS security threat is the DJ domains. It's really so sophisticated, so complicated attack techniques. So actually how it works, and for example, user visits a malicious website or a domain in before, and the client's machine is infected because of his already downloaded the malware or bot to his device. So after the execution of the malware would like to get the seeding from the attacker's AGD seeding, and so attacker knows that which time these seeds are generating from the algorithms, and it's directly to send out these seeds of the malware propagations. Okay, so and domains are generated and DNS queries are really directly sent. And the critical point is that lots of AGDs are generating, but they are 99% of these domains are going to no IP address. just only one IP address is registered, and attackers know that. Attackers know which domain names will be registering with the IP address. And then if they click the IP registration in that time, and all of the bot network directly to going to querying to this server, and it's a huge activity. Especially attackers and adversaries are using these techniques, DJ techniques, for especially DDoS attacks. And so we have seen in 6 years ago, it's the Mirai botnet. Mirai botnet has been manipulated with DJ domains in the zombie devices. Okay. For example, some malware family you can find. Popular malware family are using DJ algorithms. Primary functionality is always CNC. And for example, CryptoLocker has used DJ domains. For example, Ramnit, Xpro, Configure ABC variants. Lots of malware families have already used DJ techniques, and it's you can find the seed algorithm on there, and it's so easy, so basic. But the attackers, the attack of the attack life cycle of the threat is really so complicated, but in the algorithm it's so simple. End of the day. So you can find also the another details about DJ domains in the MITRE attack framework, and in the under the command and control tactic. You can find the details and how you can mitigate, how you can detect DJ techniques in your network. And also APT41 has used DJs to change their CNC service monthly. So APT41 is always using the DNS manipulation techniques like DJ domains, like tunneling techniques. So we are facing lots of malware families in the organizations, especially in the DJ domains. The another popular techniques is the punicode or homoglyph attacks. Actually, this attack is a deception technique that uses homoglyphs or homographs, in which an attacker abuses the similarities of character scripts to create phony domains of existing brands to trick users into clicking. Like, for example, you would like to go to apple.com, but it is not apple.com. If you want to get the details on the certificate viewer, you are not going to apple.com because it has not been generated on the UTF-8. It has been generated by Kirill alphabet. So you will be seeing the A is okay, A is normal, but A is not normal because it has been already generated with Kirill alphabet. So you can find these details in the newer versions of the browsers, by the way. Newer versions of the browsers are detecting the homoglyph techniques, but some of them are still missing. For example, in our database, would like to get a screenshot on there, and you can find the Apple targets. Lots of domain names have already been manipulated with homoglyph techniques. You can find in details on there, and yeah, we face not only Apple domains, and Facebook, Google, lots of popular domain names are being manipulated by homoglyph attacks. Okay, and also you can find the details in the MITRE attack framework under the resource developments in the pre-attack phase, we can say. And some of the APT groups are also using the homoglyph attacks in their DNS attacks. So in the first parts of this session I would like to mention about what is the popular DNS threat, and what is the main tactic, and what is the main techniques on these DNS security threats. And to the second side, I would like to mention about what is the DNS layer security challenges on the organizations. What's the main challenges? Yes, organizations are facing lots of IT challenges, IT security challenges, but in specifically, what is the DNS layer security challenges? And we would like to list with 5 points. The one of them, actually, the protection tools are missing in the DNS layer. So we are facing this challenge so much in the organizations. Yes, for example, most organizations are using firewalls, endpoint security tools, some sandbox technologies, some another detection tools like EDR, NDR, but most of them are just only focusing the specific area. Like firewalls are just only inspecting the web traffic, and the email gateways are just only doing the inspecting the email traffic. But DNS is missing for prevention or protection mechanisms. So we need to build a protection mechanisms for DNS layer, because DNS is a starting point of the communications. If you want to if you want to get a HTTP session, you need to first get a DNS query for your local DNS servers. So we need to build a protection mechanisms on the first defense parameter. Another point is the DNS logs are not centralized for analysis. Most organizations are using distributed DNS servers in their network. So, and most organizations don't want to collect the DNS logs in centralized environments. Mostly they are using SIEM or log management tools, but they don't want to get these DNS logs because they are really so huge. For example, in average, and one client is doing 70 and 100 DNS queries in a day, and it's really so much huge. And for example, 1,000 clients in the organizations, there is really so much DNS logs, and most organizations don't want to collect DNS logs. But another challenge, the DNS logs need to be collected because of the you need to get a visibility on there, and you need to get cover your regulations and compliances in the end of the day. So DNS logs are so important for us, and how we can overcome this challenge, I will be talking about in the another part of the session. Even if you have logs, even if organization are collecting DNS logs on their local DNS servers, okay, but they're not sufficient to identify security threats, because I have mentioned on that DNS threats are really so sophisticated, so complicated, and you need to build correlated rules, and you need to develop new use cases for the DNS perspective. Okay, so it is not sufficient to identify security threats. It is the another challenge. The other challenge is the signature or indicator-driven analysis are not enough. So mostly security tools are using just only signature-based. Okay, so for example, most firewalls are doing URL filtering mechanisms. Okay, they are just only looking at in the signature list, and this URL is malware, this URL is the another categories, and I'm blocking, I'm blah blah. But it is not true perspective from our side, because we do not track only URLs. We need to track the base domains and also subdomains and the FQDNs, all of the internet. So and these domains mostly is using in the variable and dynamic categories. I will be talking about what is the variable categories, what is the dynamic categories on the domain names. I will be talking on point, but not only signature analysis is enough, but also we need to build heuristic and behavior analysis to detect DNS security threats. The another challenge is manual deep processing of DNS logs is really slow and cost prohibitive, because most organizations are using SIEM or log management tools, and they do not want to collect the DNS logs, because they are collecting DNS logs to their SIEM environment. SIEM is going slowly. It is affecting badly, and also EPS cost is the another challenge for SIEM environments. If you want to send so much data, so much log to your SIEM environment, it will be exceeding your EPS license. So the another challenge we can see. So the third part of my slides, I would like to talk about the DNSSense solution sets and DNSSense product line. And who is DNSSense? DNSSense is a domain categorization and declassification company. And we are doing just only this work as cybersecurity perspectively. We are not doing any classical or any classic WHOIS company. We are doing domain classification as cybersecurity perspectively. And we only use AI. We are not doing any human intervention for our AI engines, and AI is judging all of the internet, all of the base domains. We track 550 million base domains in just only one day. Every day we are tracking, and in 4 days we are crawling 3 billion subdomains and FQDNs. It's really huge work for us. We reclassify 3 million domains in one day because we know that the internet is so much variable, it's so much dynamic. So we need to reclassify of some of domains like domain parkings, like dead sites, like NX domains. They are so critical because we know that the malicious are malicious. Because malicious activities are starting, attacker is starting his activity, and then after 2 hours, it is closing all the domains with IP addresses. So you are not tracking if you are not doing any real-time tracking mechanisms, you couldn't find any phishing attacks. So we need to track all of these base domains in every day, every hour. Okay, we guarantee to categorize, firstly seen, not categorize in worldwide in just on 10 minutes, and we set 800 features. It is really so wider list for looking or each domains. Half of them just only we are looking to CTI services, and the another half of them is we have already set our features for the AI engine. We support 74 languages for domain classification, and in briefly I can say DNSSense is a domain classification company, domain categorization company, and our most valuable asset is that in the company perspective. Okay, what we are doing the domain classification differently. We divide internet to 4 main class, not only safe, malicious, or restricted content. We know that. We know the safe and restricted content, mostly security vendors, security professionals know that the safe domains are safe domains, and restricted content and restricted in the end of the day. But malicious and variable, we are just focusing on that area. We are not doing any content filtering of these domains. We are just classifying. Malicious is our it is dangerous area. We know that, and we have some subcategories on there. For example, botnet, CC, DGA domains, hacking, malware, virus, proxy, spam sites, phishing, and all categorizations are directed to map the malicious class. But the another class is they could be dangerous. It is so dynamic. I have already mentioned on that, like that sites, dynamic DNS addresses, firstly seen addresses, newly registered addresses, newly up registers. We are tracking all of them on the internet. So they could be dangerous, and attackers are really so motivated to use this area for starting their DNS security attacks. So we are focusing on that side. What is our product line? We have 3 products, and one of them is the Secure DNS. A Secure DNS is a cloud-based protection tool. It is fully SaaS platform and it's fully cloud platform. And we have all our own IP addresses for resolving DNS queries. And also we are supporting roaming clients and the DNS relay mechanisms for also forwarding mechanisms. We are supporting this product in the end of the day. And this product is, we can say, traditionally DNS firewalling, because we are doing blocking and enforcement for the DNS queries of the organizations. The second product, we say the second product is our main motivation, our main area of is this product, because it is a only and exclusive product for us, and it is doing the DNS layer analysis. So we are just doing the DNS layer on the site, and we are collecting the DNS logs, and this product is working like the SIEM, but it is not a SIEM solution. We are collecting the DNS logs on the local DNS servers on the organizations, and we are enriching, we are classifying, we are categorizing, we are judging, we are reporting all of the DNS queries of the organizations. And we are not doing any integration, we are not doing any API integration, script integration, like those works we are not doing, because we are just reading the DNS debug logs with the local DNS servers. It is so easy, it is so simple to deploy, and it is so valuable product to get more security visibility on the DNS layer. And also security gap functionality and SIEM integration and EDR integration have in this product. And I will be talking about how these functionalities are working in the product backend. In the third product is the Cyber X-Ray. It's a dynamic cyber threat intelligence service, and you can find all the historical and relational data with writing down which you want to investigate domain names. You are writing just on the abc.com, you are finding all historical data. What is the whois data? What is the whois privacy data? What is the IP relations, subdomain relations, in-link and out-link relations? It's so important. And what is the relations on the crawling and the CTI services? And so all of these informations you can find with this product. All three products are natively integrated in the backend, and also one database is feeding all of these three products. It is our database is our most valuable asset in Nando today, and all of these three products you can find this value with each of these products. I have mentioned on that secure DNS is a cloud-based protection. We are protection mechanisms for customer, and we are supporting the AI-based domain classification. I have already said about that, and it is our main value with this product. It is traditional DNS firewalling. Our main value is that we are approaching the zero trust approach with this product, and we are delivering the positive security, because we can say to our customer, and we can deliver our customers to configure to block first the SIEM domains, for example, to block dead sites and domain parking domain names, and then the customers can easily configure, and they can easily block these domain names with using this product. So it's a fully cloud, and it's so easy. And we have three deployment methods with this product. For example, we are doing the DNS forwarder mechanisms. The first and mostly we are using the DNS forwarder. We are just writing the forwarding list to the organization's DNS servers, and it is directly with to resolve. So the second one is the DNS relay, and we have the relay mechanisms. We are putting a server in front of the local DNS servers, and all of the DNS queries are coming to us. And after that, we are judging, we are enforcing, and we are directly forward to local DNS servers. It's a relay mechanism. And the third one is the roaming clients. Roaming clients are easily the organizations can deploy the roaming client agents to Windows machines, macOS, and the Android and the iPhone devices, and they can these roaming clients are capturing the DNS queries in the endpoint edge, and directly these queries are sending to us to our cloud DNS servers. Okay. Let's talk about the DNS visibility. As I have said, this product is our most valuable product, and because it is the only product, by the way, for DNS security competition area, because there is no any product like this in our competitors. And we are doing the advanced DNS analysis, and we are doing this work, not any change in the DNS network infrastructure. We are not doing any changes on the DNS network infrastructure, because we are not doing any API integration, or we do not want to change their IP addresses. We are just collecting the DNS logs on the local DNS servers, and also we are doing some source IP enrichments, because this product, secure DNS product, is gapping. Actually, is missing a point. What is this? What is this gap? Actually, the gap is you couldn't find the local IP addresses. It is a generic problem, by the way. All the cloud-based DNS firewalls are missing these points. They are just only just see your public IP address, which public IP address is querying to me. So all of the vendors are doing this like this, but it is a problem, because organizations want to get the visibility which host name, which local IP address have already queried this these domain names, and and this product is solving this problem. And this product is directly collecting DNS logs, and we are getting the local IP addresses, and we are enriching this local IP address with MAC address and the host names. Also getting collect DHCP servers logs, and we are enriching of these matching mechanisms. This product is also integratable product for the another security devices like SIEM, EDR solutions, and I will be mentioning on that. What's the main use case with this product? This product is infected device detection, because in just only one line you can find the details. What's the timestamp? What is the host name, local IP address, MAC address? What's the user? Which user is doing that? And what is the domain name? What is the subdomain name? What is it is categorization? It's a malware or variable or dynamic DNS addresses. And what is the destination IP address and the country? Like those informations and those enriched data you can find just only one line. And it is so easy to show out which infected device you are facing in your network. Okay, for example, 6 months ago, some organizations have hit a cyber attack, and the CM is not alerting of this cyber attack, and the organizations have aware, oh, 6 months ago I have got a cyber attack, but what's the detail? They couldn't find the detail, and some attackers are getting some clues on the network. So, for example, they are putting some malwares, and the malwares are just only doing the same DNS queries, but you would like to investigate the DNS queries. These domains, domain names are that sites, and you couldn't find any information in that point, and we can easily show out which zombie devices are doing these DNS queries, still doing these DNS queries, and we can show out this use case for our organizations. The other valuable functionality with this product, it's a security gap functionality. This functionality is working for assessing the existing security tools like firewalls, next-gen firewalls, proxy devices, or the another third-party DNS firewall, or the third-party secure DNS product. we are assessing them. Those devices are blocking or those devices are passing with our malicious FQDN list. But this malicious FQDN list, it is not our all databases. It is just only visited domain names from the organizations. So we can easily show out what is your gap. These domain names have already hit it in your network, in your DNS servers, and your firewall is passing, and your proxy is passing, but it is still those domain names are variable domains, and those domains you need to block, but your firewall is not blocking. So we can assessing this gap for our customers, and it is a valuable functionality for this product. The another valuable functionality is the SIEM integration. What was the challenge? Challenge was most organizations do not want to collect DNS logs locally in the local servers, but they need to collect because to get more visibility on the DNS layer, and also to cover all of the, for example, regulations or compliance issues. So in the end of the day, there is a challenge on that point, because if they have logs on the SIEM environment, the SIEM is really going to is increasing dramatically on the EPS count. So most organizations do not want to do that. So we are doing a SIEM simplifications, we can say, because with this integration, we are directly to send out just only one log to SIEM. It is an enriched data, and we are our number is the 1/1000 for low log submission, and we are reducing the cost of EPS licensing on the SIEM environment. And this functionality is supporting the JF and the LAF log format support, and it's a really good functionality to especially to send out, to get out actually DNS logs on the DNS on the SIEM environment. The another functionality, the EDR integration, it is also valuable because most organizations want to get this information. What's going on in my endpoint? Yes, this endpoint is doing this query. Okay, great. And you are categorizing this domain as malicious, or it's a dead site, or it's a newly registered or newly up domains. Okay, great. But what's the root cause? I would like to get this root cause with this EDR integration, and which processes or which registry activities I can easily show out. These processes are triggering these these DNS queries with this integration use case. And lastly, the third product is the Cyber X-Ray. It's an AI-based domain classification portal. It's a cyber threat intelligence service, and this database, it's really our own AI-based database, and it's so valuable asset for us. And so you can find the details, the historical and relational data of domain names which you want to investigate. And it's simple portal, and you are just writing down your domain names, and you can find all the informations like certificate informations, who is privacy, IP relations, subdomain relations, in-link and out-link relations. It's so important for investigation, and we can easily show out all of this information to especially like enterprise SOC analysts or security professionals or SIEM admin. And you can find these details with this product. So my presentation is like that. And first of all, thanks for listening me for the presentation. If you have any question, I would like to answer that.
Let's see on the chat. Anybody any question? Please write there. raise your hand. And so maybe a question is that, what kind of attacks, because you guys see lots of DNS stuff, right? So what kind of attacks are you seeing in the real world of that list you had in the beginning?
Yes, actually, let's remember, actually, we are facing lots of DNS tunneling and the DJ domains in nowadays. So they are so popular for the DNS layer security threats, and we are facing so much. And our security team is is detecting so much these activities. And yeah, it's so popular. I can say the tunneling techniques and spoofing techniques also, and the DJ domains are really so popular. And the another ones, of course, adversaries are so motivated to use the another DNS layer security threats, like especially DDoS attacks for using the DNS amplification.
Yeah, do you guys have your own infrastructure? You build yourself on top of AWS and the cloud providers?
Sorry, Dennis, I couldn't get.
So do you have your own infrastructure, or you build on top of one of the cloud providers?
To show a demonstration in them?
Well, no, basically, to hold DNS traffic, right? Because one of the things that, for example, in AWS, they have quite a lot is the ability to absorb a lot of, malicious traffic, right? So it's almost becomes a case of who has the biggest pipe.
Definitely. This infrastructure is feeding by 10,000 customers. It's really so huge traffic. We are analyzing so huge DNS traffic, and also our AI engine is good in that point, because AI is just only judging for all this DNS traffic. We are not inputting any human intervention on the AI, and AI is just only judging for all the traffic, we can say.
All right, let's see if any more questions here. Okay, cool. So there's a question from Daniel. It says, malwares and even exploit kits can use DDNS services as part of their payload distribution. What are some of the practical security considerations to protect against these distributed DNS services?
Mm-hmm.
So that's so basically talking about the malware and exploit kits use that, right? So what can you do to protect that?
Yeah, actually, in the protection mechanisms, we need to build. First of all, we need to build to get a analysis of the DNS traffic. The first of that, we need to build this system, and also, of course, the malwares and the exploit keys can utilize, especially in the dynamic DNS services. And we are facing so much, but in our domain categorizations, we are dividing the malware categorizations, and we are also dividing the dynamic DNS services. Some dynamic DNS services are just not only using the malware propagation or the exploit kits activities, but also there is another techniques are using on the dynamic DNS services, like, for example, phishing, like, for example, CNC activities. Those activities are also being used by dynamic DNS services.
Cool. Yeah, so dynamic DNS, sorry, Prakash, it's not distributed, it's dynamic DNS attacks. Cool. All right, brilliant. All right, thanks for doing this session. I love the first initial part where you really had a great presentation of the state of the art of DNS, the DNS world. That was really, really cool. And I hope to see you at the next summit.
Thanks a lot.